Question 17 asks us to use ray diagrams to find the location of an image that is formed by a lens, find the magnification of this image, and whether it is real or virtual. So we do this by making ray diagrams with the principal rays. One starts from the tip of the image, goes through the first focal point, and then parallel to the axis here. The second diagram goes straight through the middle of the axis, and the third line ray goes parallel to the axis and then through the second focal point. And since they all converge right here, we can tell that that is where the image is formed. And to find the distance of where the image is, we can use the equation 1 over p plus 1 over q equals 1 over f, with this being our p value and this length is our q value. So we plug in 1 over 8 for p and 1 over 4 for f and solve that q equals 8. Once we find q, we can plug it into our magnification equation, which is negative q over p, and we find that the magnification is -1. And since the image is more than one focal length away from the lens, it's a real image. And then we do the same thing for number 2, but this time when we draw the lines, we have to trace them backwards to find where they converge. And so they converge to form an image back here. And we did the same thing with our equations, plugging in 1 over 2 and 1 over 5 for p and f to find that q equals -10/3. And then the magnification is 5/3. And since the location of the image is less than one focal point away, it's virtual.
All right. Part 3 is a little different from the other two parts because we have a diverging lens now, and that means we draw the rays a little differently. So the top ray goes parallel to the x-axis, and then this line traces back to this focal point over here. The second line in the middle is parallel to the x-axis down here and traces back to this focal point. And then the third line goes straight through the middle of the lens. So where these three lines intersect is where we expect the image to be. So for these values, we used 4 for p and 6 for f, found q to be -10/24, or 1 over q to be -10/24, and q to be -24/10. The magnification with that formula, 24/10/4, gives us a 3/5 magnification, so it gets smaller. And since the image is less than one focal length away from the lens, then it is a virtual image as well.